Okay, today we're going to talk about standardizing and z-scores. This is kind of new information. We haven't seen it before, but it's not too bad. So let's go ahead and take a look at definitions. All right, so z-scores, that's the number of standard deviation a given value is away from the mean. When we standardize z-scores, it allows us to compare two values by standardizing them, by converting them to z-scores. Okay, so when we convert something to a z-score, we can compare things that sometimes we can't always compare. We talk about can't compare apples to oranges. One big argument right now is who's better, Michael Jordan or LeBron James. We can't really compare them right from just their normal stats because they played at two different times. But using z-scores, we can actually do that. So our formula for z-score is right here. So z equals our x, that's our value. Okay, so I'm going to go ahead and put value right here, what we're trying to look at. Okay, this little u stands for the mean or the average. And this little, kind of looks like a apple almost, is standard deviation. Okay, so they'll give you two of those values, and you have to compute the z-score. So let's look at an example. Okay, so for this example, it says the set of numbers has a mean of 7 and a standard deviation of 4. Find the z-score of the value of 9.6. So remember, our formula is z equals our x minus our mean all over our standard deviation. So I'm just going to go ahead and plug in my values. My value, or my x, is 9.6 minus my mean, which is 7, okay, all over my standard deviation, which is 4. Okay. So when I do this, I'm going to do the top part first, hit enter, and then divide by 4. So when I do that, I do 9.6 minus 7, which is 2.6. So I just have 2.6. Now I'm going to divide that by 4, and I get 0.65. So for z-scores, we're going to round to 2 decimal places. This one ends at 2 decimal places, so my answer is 0.65. So my z-score for this number, 9.6, is 6.5. All right, so I have a math test had a mean score of 71 with a standard deviation of 4. The history test had a mean score of 78 and a standard deviation of 5. If you scored a 77 on the math test and an 84 on the history test, which test did you relatively do better on? Okay, so we can compare these two test scores using z-scores. Okay, so let's look at your math score first. So if I look at my math, my score for math was my x value, which is 77. Then we're going to subtract our mean, which my mean was 71, with the standard deviation of 4. So 4 is going to go right here. So when I plug that in, okay, 77 divided by, or minus 71 is 6, divided by 4. 6 divided by 4 is 1.5. Okay. Now let's go ahead and get our history score. So our history, we got an 85, so that's my x for my history. So 84. So 84 minus my average for my history, which is 78, all divided by my standard deviation, which is 5. Okay, so that's going to be 6 over 5. Well, 6 over 5, if I do that in the calculator, it's 1.2. Okay. So now if I kind of look at these, okay, my z-score, here's kind of a visual to see it. Okay, 0 is our average. So if you're at 0, you're average. Okay, my math score, I was a 1.5, so that's going to be about right there. That was math. Okay, my history was a 1.2, so that's going to be between those two, and that one was my history. Okay, so if we want the one that we did better on, well, if 0 is average, we want the one that's furthest away from average, because the furthest away from average that we are going positive, the better we did. Well, the one that's further away is math, so math is the score that we did better on. Okay, so we looked at our z-scores and then we compared which one is further away from average or more above average. Well, that was the math score. All right, let's look at another example. All right, so for this one, Samantha was at a fair playing a basketball game and a ring toss game. Samantha made 13 baskets, and the mean number of baskets made is 11, with a standard deviation of 1.5. Samantha also got 16 rings on the ring toss game, which the mean of 12 rings and a standard deviation of 3.8. Which game did she relatively do better on? Okay, so now we're comparing these two games, so let's go ahead and do the basketball game first. I'm going to actually just go ahead and put BB for basketball. Okay, so she got a 13 minus the average, which is 11, or the mean, divided by the standard deviation of 1.5. So I'm going to go ahead and do this. This can be 2 over 1.5. So I'm going to do that in my calculator. 2 divided by 1.5. And it is 1.3 repeating. So I'm going to just do 2 decimal places. Always do 2 decimal places with these z-scores. Okay. So let's go ahead and now do the ring toss game. So I'm going to go RT for ring toss. I'll go ahead and switch colors. I'm going to go to blue. Okay. So ring toss, our score, we got 16 rings minus our mean, which is 12, all divided by our standard deviation, which is 3.8. All right, so that'll be 4 over 3.8. So then I'm going to go ahead and do that in the calculator. 4 divided by 3.8. And I got 1.05. Okay. Now, I want to know which one we did relatively better on. Okay. So if I think about this, here's 0. Okay. If this was 1, then 1.05 would be right here, which would be the ring toss. And then 1.3, so if this is 2, 1.3 would be right here, and that would be basketball. So which one is further away from the average or further away from 0? Well, basketball is. So my answer, the one I did better on, would be the basketball game. So I'm going to go ahead and put basketball. All right, and that is our answer. Go ahead and get started on your class kick. Ask questions if you got them.